Hello friends, this is Professor Dattu Patel. Last lecture we learned about differential equation solvable for P, that is case 1. Case 2, which is differential equation solvable for Y. Today's lecture we learn about differential equation solvable for X, that is our case 3. If differential equation can be written in form of x equal to f of y comma p, that is our equation number 1, then it is said to be solvable for x. Differentiating equation number 1 with respect to y, we get del x by del y equal to del f by del y plus del f by del p into dp by dy. Here dx by dy, that is indicated by 1 upon p. Substitute this value in this equation and equation takes from, which is 1 upon p equal to f of function of y p dp by dy. That is our equation number 2, which is first order and first degree differential equation in variable p. Now we solving the equation number 2 with the help of variable separable method, and we obtain solution of, which is g of y p c equal to 0. That is our equation number 3. Now eliminating the p from equation 1 and equation 3, we required solution of equation 1. We get the required solution of equation number 1. That is the steps for solving the solvable of differential equation for x, and same steps which is already learned in last lecture, case 2 solvable for y. In both the case, if it is not possible to eliminating p, some of the example we can't eliminating the p, at that case we obtain general solution by taking x equal to f1 of p comma c and y equal to f2 of p comma c. That is equation number 4, where c is an arbitrary constant. Case 2 and case 3 both are same, but only single difference, one difference between this both the case. First one, in this case 3, here we become the subject as a x, and case 2 we become the subject as a y. Only this difference, remaining procedure are same as for solving the example. Let us start with one example. First of all, whatever the differential equation given in question, we convert in form of f of x comma p in case 2 and case 3 to become the subject x as a differential equation. First example, solve y equal to 2px plus y square pq. First, our differential equation here, given differential equation can be expressed as a x equal to f of p comma y. Means in this differential equation, to become the x as a subject, then 2px equal to y minus y square into p cube. Then x equal to 1 by 2 y by p minus y square into p square. P cancel out. That is our equation number 1. Now differentiating equation number 1 with respect to y, then we get dxy dy equal to 1 by 2 as it is here, product rule 1 by p as it is, plus differentiation of 1 upon p which is minus 1 upon p square into y dp by dy. Here again product rule minus y square 2p dp by dy minus 2y p square dy by cancel. Then here dx by dy equal to 1 upon p. Then substitutes this value, means 1 upon p, then 1 by 2 1 upon p minus 1 upon p square dp by dy minus 2y square p dp by dy minus 2y p square. Now taking LCM, which is 2p square, then we get here 2p square means pp cancel out, equal to p minus 1 upon minus y dp by dy minus 2y square p cube dp by dy minus 2y p raised to 4. This all the terms comes this side, 2p minus p, then we get p plus y dp by dy plus 2y square p cube dp by dy plus 2y p raised to 4 equal to 0. Now in this term common which is p, then we get 1 plus 2y p cube. In this both term y dp by dy which is common, then 1 plus 2y p cube. Then we get 1 plus 2y p cube and p plus y dp by dy equal to 0. Now discarding this term, discarding 1 plus 2y p cube, because which does not contain dp by dy. Consider only second term, which is p plus y dp by dy equal to 0. We solve this equation, means p equal to minus dp by dy. We require this equation at the end of example. Then I return this equation top of the board for the further use, which is required at the end of the example. Due to insufficient space, now with the help of variable separable method. By variable separable method, we find the solution of this differential equation. Means dy by y plus dp by p equal to 0. Then apply integration both sides. Means ln y plus ln p equal to ln c. Then taking antilog, then p equal to y by c. That is our equation number 2. Now we eliminate the p from equation 1 and 3, 1 and 2 by eliminating p from equation 1 and 2. Means substitute the value of p in this equation and we get x equal to 1 by 2, y, p means y by c, minus y square, p square is y square by c square, y cancel out. Then x equal to 1 by 2, c minus y raised to 4 by c square, taking LCM. Then 2x c square equal to c square minus y raised to 4, which is required general solution. Another example. Example number 2. Solve x equal to p plus 1 upon p. In this example, here given differential equation is in form of x equal to f of y comma p, which is solvable for x. That is our equation number 1. Now differentiating this equation with respect to y. Differentiating equation number 1 with respect to y. Then dx by dy equal to dp by dy, 1 upon differentiating of 1 upon p, which is minus 1 upon p square, dp by dy. Now dx by dy, then we can write 1 upon p. Dx by dy equal to 1 upon p. Substitute this value in this equation, and dp by dy, which is common, then we get, taking LCM, then p square minus 1 upon p square, dp by dy, then 1 upon p cancel out, then 1 equal to p square minus 1 upon p into dp by dy. Now with the help of variable separable method, then dy goes this side, then dy equal to pp cancel, then p minus 1 upon p into dp, taking integration both sides, then y equal to p square by 2 minus 1 upon minus ln p plus c. Here we cannot eliminate p from equation 1 and 2. Here equation 1, which is question our x equal to p plus 1 upon p, and equation 2, which is y equal to p square by 2 minus ln p plus c. Then here we cannot eliminate p from equation 1 and 2. Therefore, general solution in parameter from is, then our solution is x equal to p plus 1 upon p and y equal to p square by 2 minus ln p plus c, where c is an arbitrary constant. In this example, we cannot eliminate p from equation 1 and 2. At that case, our general solution is in form of our parameters. Then parameter is x equal to p plus 1 upon p and y equal to p square by 2 minus ln p plus c. Similarly, same case happen in case 2. Then also we solve same as x and y in place of our solution, where c is an our arbitrary constant. If you have any doubts regarding these lectures, feel free contact me. Thank you so much for listening this video.